Hello, everyone, and welcome. Thank you for joining us for today's session. Before we begin, I'd like to review just two items. Our code of conduct. So Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat. You can comment, you can ask questions. We just ask that you remain professional and on topic. If you have not done so already, that brings us to our next slide, the event guidelines. You should create an account for YouTube so you're able to access the chat and interact. If you haven't done so yet, now is a great opportunity to do that. This session obviously is being recorded. It's on YouTube right now, streaming to you live. It will be available for on-demand access through the Microsoft Reactor YouTube channel. Any links we share on this session we'll be sharing in the chat, and then later we'll be updating the recording's description so that you have access to that as well if you ever need to circle back and reference. And now to our main event. So today we are joined by Louise Hahn. She will be covering low-code tutorial and anomaly detection in Synapse. This session should run for about an hour or so. Questions can be asked throughout, but we will most likely be answering those toward the end. For now, I'm going to bring myself and the speaker up on the screen. Hello, how are you?
Yeah,
Welcome,
hi
Louise.
Rebecca. Hi,
How
how
are
are
you?
you? Yeah, I'm
I'm doing
great.
great. We already have a good amount of people tuning in. And I think we're ready to get started. So I will let you take over if you want to intro yourself. And did you want me to pull up your slides?
Yes, please. Thank you.
Okay, perfect. So your slides are up on the screen now, and you can take over from here.
Great. Thank you, Rebecca. And hi, everyone. This is Luis, and I'm the program manager of Anomaly Detector service. So in today's meeting, in today's session, I will give you a really great local tutorial, which is Anomaly Detector in Synapse. So after this session, I hope you can get understanding of what is Anomaly Detector, what is SynapseML, and also how you can do anomaly detection in the Synapse. So without further ado, let's just jump into today's session. So the overview or the agenda will be as followed. The first, I will show you what is Synapse ML, and the second is what I will show you is anomaly detector in cognitive services. And the second, I will do a great demo about how you can do anomaly detection in Synapse Analytics. And the fourth is what you can do or where you to go from here. Okay, let's just jump into the first part. So let's just talk in a nutshell. Today's session or this collaboration is between two teams within Microsoft. So first is the Apache Spark on Synapse Analytics, and the second part is Anomaly Vector as a cognitive services. So if you are not familiar with SynapseML, I can give you a really brief introduction. So SynapseML is a released open resource as part of Microsoft ML for Apache Spark. And this project aims to unify all of the Microsoft contributions under a single API and framework. We have several distributed ML frameworks, the ability to deploy models, the ability to integrate HTTP services into Spark clusters as well. Finally, everything in the library is automatically exposed to all of the Spark languages through a binding generation system. So as you can see here, with just one simple ML API, we can have all these amazing functions. So today's session, we are only targeting at the cognitive services within SynapseML. So give you a really quick overview of what it can do with the SynapseML. So after we give some input like this, some data, some date, and the value. Sorry for that. Yeah, after we give the date and value, and we just use one function called the estimator in SynapseML. And with this, you can quickly get the output of whether it is an anomaly. And within this process, you don't need to do a lot of work or a lot of code work here. So you just give some input like the specified column name and the granularity, etc. Just the basic some settings. You can get the results immediately with this quick and easy to understand estimator. Yeah, so next, let's just jump into what is an anomaly detector in cognitive services. I believe most of you might heard of Azure Cognitive Services. So within these services, we have four pillars. The first one is language and the speech, vision. Also, there is decision. And actually, our team and our product, Anomaly Vector, is seated in this decision pillar. You might not be really familiar with that. That's okay. So that's why I'm here to tell you about the amazing thing about Anomaly Detector. So basically, this is a workflow of how you can use the anomaly detector. First, you will have some time series data, and with an API of anomaly detector, you can do the anomaly detection with some building models and also with your trained models based on your data. And after that, you can use the API to call the results of your inference process. So that's the anomalies. And this overview is really simple to understand. Let's go deep into the value proposition of anomaly detector. So first, it provides simple REST APIs and SDKs that you don't need no or little AI knowledge, and you can detect anomalies from spec source dips, deviation from cyclic patterns, or trend or level changes. And most important, you can also detect some anomalies within the correlation changes between or among your variables. And the second thing is that you don't need to provide your labels. So our service, the anomaly detector, is an unsupervised model for customers to use. And the third is that sometimes the customers might have some needs like deploying on edge services. So we both support cloud and edge service for you to use the anomaly detector. And next, I will give you an overview of anomaly detector service features. So within anomaly detector APIs, we provide two features, or you can say two features to services. The first one is the univariate anomaly detection. And the second one is the multivariate NonDetection. So I believe most of you have already noticed the difference between these two features, right? The first one is to detect a variable just for one, sometimes like revenue or cost or just the methane emission leak concentration. And for the multivariate detection, it will detect anomalies within or among multiple variables, like 15 to 20 or even hundreds of variables. So the difference between this is that when you are doing some anomaly detection, just on your really one critical variable, you can just choose the univariate anomaly detection. And sometimes if you have an equipment within it, you have like lots of sensors that you want to detect and to see whether there are some anomalies within the sensor and also whether there are some anomalies in your equipment. So that's the time you can use the multivariate anomaly detection, because within this equipment, the sensors will have some correlations with each other. For example, the temperatures and the pressures, vibrations, etc. within one equipment, that will probably have some correlation with each other. So in that case, you can use multivariate anomaly detection to detect correlation changes within that. And with this service, you can tell that whether at this timestamp your equipment is in a severe mode or in a healthy mode. And the algorithms behind the scene for univariate is that something like model selection. So basically, we have a model pool with multiple models, and after you give your data to us, our model or our service will select a better fit model for your case based on your data pattern. And for multivariate anomaly detection, it's a little bit different. You should use your data to train your own model, and the algorithm behind the scene is the graph attention networks. So we will use your data to train a model that can face your scenario or use case, and then use your trained model to do the inference part. So that's basically the difference between these two features. And next, especially in today's session, I will give you more introduction of multivariate anomaly detection. So this service, as I just mentioned, it can detect anomalies within your equipment, especially your really expensive equipment or your really comprehensive and complicated system with a lot of variables. And within that, you can both see these two results. The first is that one, there is an anomaly. That's the really important thing that we want to take care of first, right? And after that, we can also give you the results of the top contributors. Why we need that? Because sometimes if your equipment has like hundreds of sensors, you cannot like analyze or take care every line, every time series, every variable, right? You can just focus on the really important sensors. So that's why we will give you the output of the top contributors to tell you that sensor 1, sensor 2, sensor 3, for example, they are on the top 3 of the anomalous sensors. So you don't need to care about other sensors. You just take care of these 3 sensors and to see whether there are some problem or anomalies in the sensors itself and take actions accordingly. And also we will give you the output of the correlation change because within multivariate anomaly detection, we can detect the correlation changes between the variables. For example, after you get the results, like in this timestamp, we got the anomaly. And based on the top contributors rank, you can also see that sensor 1, sensor 10, sensor 4, and sensor 5 are the top 4 contributors. And they're with a really high contributing score, which is a percentage number. And based on that, you can also see that sensor 1 will have correlationship with, for example, sensor 10. So that is kind of a root cause analysis to help you to find which sensors are have some correlation and their correlation changed a lot. That is causing the anomaly. So that's a really amazing thing for you to do the further analysis and root cause analysis based on the anomaly results. And with the multivariate anomaly detection, we provide basically 8 APIs to help you to train, model, and inference on the model. And you can also list the model, delete the model, etc. I know the list will be a little bit hard to like get a sense at the first glance. So that's why I generate this kind of picture here to show you the workflow and the category of these 8 APIs. So with these 5 blue APIs, that's really the essential part. You first will train the API with a training model API, and then use the API to get a model status to know whether it is having some errors or it's running really successfully. And then you will use your trained model to do the inference. So for inference part, we provide 2 kinds of functions. The first is called asynchronous inference API. So it's easy to understand. For example, if you use your trained model to do the inference API, probably you will use a lot of data to do like a batch inference and give all the data to the inference API. And with this API, you will not get the data, the results immediately. You should use another API called get inference status. And this will help you to get the status and get the results of your inference process. And the second option that we offer here is about the synchronized inference API. So it's also easy to understand. For example, if you are using this kind of API, you will give your data into this API, and then you will get the detection results immediately. So that's basically is more focusing on a real-time case. For example, you have your data ingestion continuously, and you want to get the anomaly detection like every timestamp for your for every time that your data ingested. So that's the case. You can use the synchronized inference API. And besides that, we also have 3 APIs that can help you to manage your model. You can list the model to see some model ID and some trained model that you trained previously. And you can also delete some model to release your resource and space. And also, you can also export the model with the export model API. Okay, so next, I will give you a real case to show you in which case the multivariate anomaly detection can help. So in this case, I will show you a topic of predictive maintenance. What's the challenges from real world in the predictive maintenance? First is that predictive maintenance is really critical for the health of physical assets, because sometimes in some oil and gas company, they will probably have a really expensive machine or equipment, or in some manufacturing or energy or supply chain, they will also have something to monitor monitor on. So that's why we will need some predictive maintenance to help the customers and help the business to avoid disaster before it happens. And the second is that manual rules settings will not scale and adapt. For example, you can define rules and set some threshold based on your data, but it will not scale. Because if you want to expand to like hundreds of models or hundreds of variables, that's really hard for you to manually to set threshold for everyone for every variable. So that's why we'll need something to help us automatically to train the model and inference model, and finally to scale up. And the third is that anomalies of individual sensors doesn't equal to the system failure. For example, if you have equipment with multiple sensors, like hundreds of sensors, and sometimes just one variable, like the temperature, has a spike or drop, that will not mean that your equipment is in a really severe mood, because that's just one sensor's problem. And sometimes this will probably just a false alarm or just a noise. So especially when you are carrying more on the system level or the equipment level, you don't need to take care or you don't care much on the individual sensors. So that's why we will need something like multivariate NonDetection to help you detect anomalies in a system level. And how you can do the predictive maintenance with the multivariate NonDetection. So first, with this, you can detect many patterns of anomalies in your system or equipment with little AI knowledge. You can detect the spikes or drops, and you can detect the trend change, and you can also detect the correlation changes. And the second, that is really easy to integrate into your enterprise predictive maintenance solutions or your platforms with just the simple REST APIs and SDKs. And third is that what I mentioned before is root cause analysis. You will not only get the anomalous timestamp, but you can also get at this timestamp which sensors are the top contributors. And you can also get the correlative sensors with the top contributors. So that will help you in the root cause analysis. And in this part, I will show you a case of how this company called Contaso to detect anomalies in their equipment. So basically, Contaso is a company in oil and gas industry, and they wanted to monitor their critical equipment on a continuous basis, but with less cost on these maintenance tasks. And they want the anomaly detected and be alerted. So Contaso talked with us and to see whether multivariate anomaly detection can fix their problem, because they already have some built-in models. For example, they use something like min-max to set some threshold to filter out the spike and drop and detect anomalies based on that. But they want to know more about the correlations between the variables, because they do have some correlations and they want to check and they want to detect anomalies among them. So that's why they think this multivariate anomaly detection from our team is really providing what they are needing. So they integrate our APIs into their own product with live alerting and monitoring to detect 15 to 30 sensors per equipment. And the inference frequency is like 15 minutes for that. And the customers now are using this in their really production stage. And finally, I think they will scale up to more models, and they have planned to scale up to thousands of models this year, and probably next year there will be 10,000 and more models. And based on their data scientists, they said that this capability is helping their engineers saving 80% time compared with human monitoring way before. And with this capability integrated into their own internal platform, the whole procedure conducts automatically and stably. And here is another case that I will share with you is Siemens Healthineers. So they are also doing this with their equipment monitoring. They are using Azure Anomaly Detector to identify anomalies in X-ray tube production within the production process as early as possible to monitor the performance of liquid metal bearings. And they use that and integrated that into their platform, and they are using that in the X-ray tube production stage and to detect anomalies before that. one thing I need to call out here is that they do a really great work on the data preparation stage. That's also best practices I like to share with you. Because in real world, sometimes the data, especially from your multiple sensors, that will not be really regular, and also that will not be really clean. So sometimes you must to do some processing work on your data. And besides, they do some really basic processing work like align the timestamps and to fill in some missing data points. They also do a feature engineering work. And this is also a really best practice we've seen from other customers, because sometimes, for example, the customer will only have three variables in this case, but when they try it out with the model first, they think these three variables will not tell them much about what they can do now and what to fix and what to take action. So what they do is to use a TS Fresh as a Python library, a package that the customer used to expand the variables from 3 to hundreds of variables. And on that, they can use the multivariate anomaly detection to detect anomalies on this expanded variable sets. And after that, they see this is having a really great value on the final inference results, and it's telling them a lot of information and insights. And also, other customers will do some feature engineering work, but instead of just expand the feature size or the variable numbers, they do something like customize the formula to do some calculation on the variables. For example, they think that this variable itself will not really align with other sensors. And what they do is to do some basic summarize or some aggregation work on these sensors, and also with some calculations with other sensors. And based on that, they see this will have a really good inference results. And that's a really great best practice I'd like to share with you. And for more best practice, I'd like to share with you in future sessions. Okay, so next, I will tell you a bit more about how multivariate anomaly detection works. For now, I think you know what is multivariate anomaly detection, and you know that how it can help for the business, especially for different industries like energy, manufacturing, oil and gas, and the supply chain, etc., even the healthcare. So what it works, I will give you a technical overview here. So first, you will prepare your data from your different sensor from the equipment. Like you can prepare the temperatures, the vibrations, and also the pressures. And then you can use the data from the equipment to do the data processing work and the training work. So I will also tell you more about the pre-processing because I know that sometimes your data will not be perfect aligned, and sometimes your data is not regular pattern, like a continuous pattern, right? Sometimes you will probably have a large timestamp or that you have some missing points. So for now, what we will suggest to you is that first, with our API, we can help you to fill in the missing data points. You can specify some method from our method pool. You can use some linear or some previous or zero or fixed number to fill in the missing points. That's also embedded in our API. And you can also do from your side, because sometimes you think you can use your own domain knowledge to fill in the missing points. That's also okay. And sometimes your data will not be really continuous, like every minute you will not get all the data for all the variables, and that's also okay. We accept that your data doesn't have the really regular pattern and is not that continuous. That's also what we are good at. We can fix and we can handle this kind of condition. And talking about the training part, we provide you two options here. So first, you can use the API that we built and provided for you. And also, you can use the new feature that I will talk more in the next slides. So that is, you can use the Anomaly Vector API in the Synapse. And after you train the model with your own data, you can use your inference data to do the inference precise. And for inference, you can trigger two methods. as I just mentioned, you can use the asynchronized inference. You can also use the synchronized inference. For example, if you're a data scientist and your maintenance engineer want to first validate the model's performance, so you can just use the asynchronized in a batch way and to detect anomalies for a batch of your data and to see whether they are meeting some your metrics like precision, recall, F1 score, etc. And then you can use that and deploy that into your own platform and product after you validate the model. And you use that real-time data to do the inference with a synchronized API. And you can also validate with your data scientist and your maintenance engineer, especially from business perspective, to see whether the real-time case is doing great on your scenario. So that's basically multivariate anomaly detection technical overview. And for now, I think you want to go deeper. So now let me tell you a reference architecture that how you can build and what's the rationale within this multivariate anomaly detection. So first of all, the training and inference data preparation part. If you are using the training and asynchronized API, you first will generate different sensor in different CSV file. Why we are doing that instead of combining them in just one CSV file? Because sometimes the customer might have some problem to align their different sensors. So they can just give us the separate sensor for the timestamp and the value, and we can combine them together and based on some rules and settings to align them on the timestamps. And then you can zip your CSV files into a zip file and upload to the blob storage. Why we are using the blob storage? Because it can accept a lot of data, because especially for this kind of a non-detection case, for the multivariate part, you probably will have a really long time range for training data and really large variable sets. And after that, you will use the SAS URL for training data and also for the asynchronized inference data for the data bus. And for synchronized inference data preparation, we really simplify the way, because if you are doing a synchronized inference, sometimes for this API, this will not need a really large input because you just want to detect one or just the two data points for one API call. So that's a way we can provide you that you can ingest your data as a JSON format into the request body for inference. And after you do this kind of data preparation, you can go to the training part to use the Azure Synapse analytics with MVAD, which is the multivariate anomaly detection. And you can also use our API or SDK. And you can also use the Azure Databricks with multivariate anomaly detection. And after you train the model, you can use the inference to do on your inference data. You can also use the Azure Synapse, and you can use the MVAD API SDK. You can also use the Azure Databricks with the MVAD, because the integration that we have engaged or we have released is integration into the SynapseML, the open library, as I just mentioned before. So you can use this open library in both Azure Synapse and Azure Databricks. And next, after you do the inference and the training, you can store your metadata and the inference results in some like Azure Event Hub or other storages. And after that, you will trigger some alerts and notifications, because sometimes the maintenance engineers will need something like to let them know that there is an anomaly happening here. So you can use like Azure notification hubs or log apps or other Azure components to do this. And finally, especially for the business level or the end users, they want to know and they want to see the anomaly patterns, like the daily anomalies, or they want to aggregate into a weekly anomalies. They can use the Power BI, function apps, etc. And they can use these kind of Azure components to deploy that and to do the visualization and the implementation. So basically, that's the overview of multivariate anomaly detection reference architecture. So next, what I'll show you is the new feature that we have engaged, and it's also the demo that I will show you later. It's the multivariate anomaly detection in Synapse. So what's the difference between this with the previous reference architecture? So here, that's the difference. For the training and inference data preparation part, you can see it's really simplified here. For example, for the previous way, you should compose your data into the zip file and upload to the blob storage and generate the SS URL. But if you're using that in Synapse, you can use any data source that Spark supports and use that as your training data path and also your inference data path, and use that to do training and to do the following inference. So with that, first, it will support more various data resources like the Cosmos DB, Elasticsearch, Custo, etc. As long as the Spark is supporting, you can just use that. And the second is that it is easier and a quicker data preparation process because you don't need the blob storage and the zip file and separated CSV files precise. And the third is that it will support the need of Spark environment, especially for this kind of multivariate case. You will need a Spark pool for you to do the big data compute. So that's why we provide you this kind of environment to do your big data compute and big data anomaly detection in Synapse. Okay, so next I will give you a demo of how you can use that in Synapse Analytics. Before the demo, I will tell you like in an overview how many works that we should do and what's the workflow to do that. The first thing is you should create some resources in Azure Portal. Actually, Azure Portal is a place probably really familiar with you guys is that you can create multiple resources in Azure Portal like Anomaly Detector, Synapse Analytics, Key Vault, and Storage Account. And these four are the required resources that we need to create in the Azure Portal. And the second is that you should prepare your data. For this part, you should prepare your data in a multivariate anomaly detection way. You can also check some restrictions and some regulations of how you should prepare your data for multivariate anomaly detection, and then upload the data to a data source that Spark supports, like blob storage, Custo, Cosmos DB, etc. And after you prepare your data, you can start training with your with the SynapseML and in the Synapse Analytics with several lines of code. And the fourth is that triggering the inference. Trigger the inference with your trained model and also check the contributor sensors to each anomaly. So that will help you to do the further analysis of the anomalies. And you can also use this kind of results to do some visualizations work or do some alerting work. Okay, so one last thing before the demo is here. You can get started with Azure Anomaly Detector from now. So first, you can join our Teams channel through this link, and you can also check the resources of the demo today. You can use the GitHub repo here to check the data I use and check the sample notebook that I use. And you can also check the latest blog that we released for how you can use the multivariate anomaly detection in Anomaly Vector in Synapse Analytics. So the blog will contain all the guidance and all the details that you will need to run this, and it will also contain some resources like what is Anomaly Detector and some documentations related to Anomaly Detector and Synapse. So okay. I think now is the time we finally go to the demo today. It's about how you can use Anomaly Detector in Synapse Analytics. So next, I will share my browser. Okay, we are good. Okay, probably it's a little bit lagging, but I think it's good now. So this is basically a workspace that I created in the Synapse Analytics. And in here, you can see there are some buttons. And when you just created the resource in the Azure portal, which is here, this is the Azure portal. You can create something like Anomaly Detector, for example. I can tap it there and see. Yeah, the first one is the Anomaly Detector service. So you can create that and based on your region and your preferred name to to set something like that, and to set your name, and also you can choose a pricing tier. If you are first time to a non-detector, you can just choose the free tier, the affiliate tier, and the review and create within just a few seconds, like 10 seconds, you can just create the anomaly detector service successfully. And after that, you should also create the three extra resources in Azure portal. And one resources is called the Synapse Analytics. So after you created that, you can just go to the Synapse Analytics, and it will lead you to this workspace. And in this workspace, the first thing you should do is that you can see here, you should attach to a Spark pool to help you to run the code and to do some big data compute with the Spark environment. So if you don't have a pool yet, you should create that through these manage pools. You can select the 3.1 or the 3.2 cluster for you to use. It's both acceptable for this case. And after you create a Spark pool here, you can just use this notebook, create from this develop and create a notebook, and then you can start coding. So first, in this block, you can see here, I'm doing some configuration about the version of the snaps of the Spark, and also some repositories and some excludes. You can just copy here from my sample notebook later that I will share with you. And after that, you can just click run. For example, for this part, it will probably run like 2 to 3 or like 5 minutes. And after you run that, you can just go to the next part, is to import some required modules from Synapse to import here, like the SynapseML and the notebook utils, and also other really important modules that we use in the demo. And this will run really quickly after you click the run button. And for example, I run this like just 1 second. And after that, you can load your data into a Spark data frame. So for that, I will first show you the data. Let me just click to the repo here. So this repo is the repo that I showed you in the previous slides. Is the link, is the same link. And in that, you can see here is the sample data that I use in this demo case. So here we have 4 columns. The first is called timestamp, and the next is sensor 1, 2, 3. So these 3 sensors are from a car, and you can understand them as temperature, pressure, vibration, etc. So you can see here I've already aligned all these sensors with just one timestamp, and this timestamp is pretty regular and clean here. And for your real case, you probably need to do something to avoid like the duplicated timestamps and to align these oil sensors in a right way, in a proper way, and make sure they are in the number is located in the same timestamp. And here I'm using like thousands rows of the variables of here. And after I prepare the data, I will use this CSV file and I'll upload that to the cloud. So you can see here, I'm uploading that to the blob storage, and I will use a blob storage data path, use this in here. And for that, I will just show you how I run with this data. And here is the result of the Spark data frame. Yeah, it's printing the first 10 rows of the timestamp and the sensors. And after that, I will go to the training part. So for the training part, I will specify some parameters and some things that we need to trigger a training process. So first is that I will use the key vault to store my secrets and some credentials like the connection string of my blob storage. So first, after I created this and specify the name here, I can specify some information about my data. For example, the start time and the end time, and also the timestamp column and the input columns. And that will really vary based on your own data. So you can just replace your data's column name here and specify the training start time and your training end time. And after that, you should specify the container name and the intermediate save, the folder name of your intermediate data. Why we are using this two is that in this Synapse, we simplify the data preparation process, and the Synapse will automatically do the data preparation for you, and they will transform the data from your data source to a data source that multivariate anomaly detection supported. So that's why you should use a blob storage to store the intermediate data. That is the data that multivariate anomaly detection will use. And after that, you can set this kind of estimator. And this is the most amazing thing about Synapse, as I just mentioned in the previous slides. So you just use this one estimator to trigger or to set some configurations on the final model, and you will use this fit multivariate anomaly detection function and to set something you created before, like the subscription key and the location, which is the region that you use for the anomaly detector's resource. And you can also cite some other things like start time, end time, container name, etc. And this will also be loaded in the Synapse notebook that I will show you. And next, you just use two row of codes to train the model. So you just feed the model with this function, and you can type some metadata of this model. And after a few minutes, because the data is really small, if you have a large data set, like you have more than 10,000 of data, that will probably need more time to train a model, sometimes like 20 to 30 minutes or even more. That will vary based on your data volume. And after you train the data, you can inference that with your trained model. So here, what you should do is just to set some really basic configurations, like the start inference time and the end inference time. And also you can set some output column like the results and errors. And then it's okay. It's just done with the inference part. And you can get the inference results for this part. And you can see here, I'm also printing some contributors that will show you in the next part. It's here. So basically, this is the output of you inference with your inference data. So what I'm doing here is more like in a batch way. So I give all the inference data here within Synapse, and it will give me all the results with some really really detailed parameter like its anomaly, severity, and some contribution scores. But if your case is more like a real-time case after validation, you can just write in something like a for loop and to run this and execute this code of lines continuously. And I will go deeper into this outputs. So first, the first four columns is the raw data that I input for the inference part. And the last columns is actually the results of the inference. So first column is called its anomaly. So it's really easy to understand. If this timestamp is anomalous, that will be marked as true. If not, that will be marked as false. And the severity actually is a number that will tell you how severe for this timestamp. And it's actually a number between 0 to 1. It's a normalized number. So you can based on this number to see whether this timestamp is more severe than the other timestamp. And if the timestamp is not anomaly, is false, here the severity will be 0. If it is an anomaly, then the severity will be something above 0. And it's really easy to compare with different variables, and it's really easy to filter out based on the severity, because sometimes when we do this inference, the results might not be your ideal results for the first glance, because probably we will give you more case of the results, and you can just based on the severity to filter out. For example, you think that the severity like below the 0.2 is not that severe, it's not anomaly based on your case. So you can just set a threshold like the 0.2, and all the thing above that you can mark this as an anomaly, and all the thing below that you can just leave it alone until to mark this is not anomaly. So that's basically a data post processing way you can do with this severity. And for the sensor series 0, 1, 2, and this three columns is actually the contribution score of these three sensors. So what is contribution score? It's actually a number between 0 to 1 to show you the contribution of each sensor. For example, in this case, you can see in this timestamp, these three variables all have the contribution score, and the largest is for the last one, is for the sensor 3. It's 0.59, etc. And the second is the series 1, which is the sensor 2, right? So for example, in this case, that will mean that the series 2, which is the sensor 3, is the most anomalous sensor. And you should just take care of that and put like most of your effort on this sensor to see whether there are some anomalies, because it varies a lot with the other two sensors here. So you can just focus on that. So that's really an amazing thing that you can just simplify the analysis work, just focus on the really important sensors instead of all of the sensors and all the lines. And after that, you can also, based on your data, based on your inference results, to trigger a visualization like this. And this will also be shared in the sample notebook in this GitHub repo. So basically, that's the thing in here. So you can see here, we see the job of these sensors, and we are marketing them as the right one. And also for here, I can zoom in. Yeah, the black line is the severity score, and sorry, the computer is a little bit lagging. Yeah, the black one is the severity score, and the red line I said is the minimum severity. So I can use this kind of threshold to set that, like below this minimum severity, I will leave them alone. I will not trigger any alerting or notifications. And the severity, the anomalies above the severity, I would just trigger them and use them for my downstream either components like the Power BI or some notification components. And this is showing the visualizations of different contribution scores for different sensors. So you can see, for example, if the sensor 2 is having a really like a big contribution scores, then the length of this sensor 2 in this timestamp is pretty longer than the other two sensors. So basically, that's a thing for how you can do the Synapse analytics and how you can do the multivariate NonDetection within Synapse analytics. And besides that, we also provide something to use in the Synapse analytics is for the univariate anomaly detection, because the univariate anomaly detection is earlier than the multivariate anomaly detection. And for this feature, we can provide you in Synapse to use just some no-code way, just to drag and drop and to write some column name here, just to set this feature, set these configurations, and then you can just run it within the Synapse analytics. And if you're interested, I can also share you with the link, and you can also to search, for example, like the Synapse anomaly detection. You can get the results and get all the information and documentations on that. And for a last demo that I will show you is actually a demo page that we created. In this part, I will give you like a recap of the Anomaly Detector, the service that we are providing. So in general, we provided these two features, the univariate anomaly detection and the multivariate anomaly detection. And the multivariate, I've already shown you the way that it works. And for the univariate part, I think most of you probably have some interest. So that's why I will leave it here for the last part. And here is the demo page. You can see I've already inputted the endpoint and the key for that. And here are some sample data that you can choose. So here I will choose the sample 1. And here you can also set some sensitivity and the max detecting window. So basically, these are some settings to help you filter out the anomalies based on your needs and preference. You can set some sensitivity like really high, like 70 or even 100. That will be something like you will detect at most of the anomalies on your data. If you set sensitivity at 0, that will mean that we accept all the things here. We don't need everything to be anomaly. So that's the basically difference between the low number and the high number. And here I can clear the start. So you can see the gray one is the sliding window here. And the blue arrow is detecting the last point of the sliding window. So every time as the sliding window goes by, we will detect the last data points in the sliding window. And you can see the request here. The request, for example, I stop here. You can see the request for this series. It has some timestamp and some values here. And for the response, you can see the expected values and whether it is anomaly, etc. So I will not keep going, but you can definitely to run and play with it if you're really interested in that. Okay, so basically that's all for today. And this too, I think is really great instructions for you to do the multivariate anomaly detection in Synapse. So as I will also share you, and I think Rebecca will also share with you guys with all these useful links of the blog, of the GitHub repo, and also how you can join our community through this link. Okay, that's all for today's session. I hope you can get some learning or some insights. And yeah, I will hand back to Rebecca to see whether we have some questions in the chat window.
Hi, Louise. Thank you so much. Yeah, we got a couple of questions that came in. I'm going to share them on the screen here for a moment. So Ishan said, can we use data in ADLS Gen 2 for training?
Yes, you can. If you're
Okay.
using the Synapse part, it's acceptable. But if you're using the API for this Anomaly Vector, you should do some data transformation from your ADLS and to transform into the blob storage and to transform your data into a data format that we accept.
Awesome. And then the next question we have is from Jack, and he asked, can we use anomaly detection to detect anomalies in streaming video?
Oh, that's really a good question. Currently, our feature is targeting at the time series data, and it's basically on the numerical data. So if you want to detect something like the streaming video or some audio, currently is not supported with the anomaly detection.
Awesome. So that is the couple questions that came through so far. I'm going to quickly just talk about the reactor here for a second for anybody tuning in that is not familiar. And maybe there'll be some questions that come through while we just quickly run through this. So if you want to just hang out, Louise, and we'll just quickly do this. So if you're not familiar, everyone, the Reactor community offers weekly content free for our audiences internationally. We have physical locations around the world for in-person sessions that we've recently started rolling back out. We also have ample sessions that are either hybrid or virtual. So you can find us on meetup.com if you're not already there and familiar with it. Just search for the Microsoft Reactor and pick a location that's closest to you or that time zone works best for your personal schedule. We're on YouTube, obviously. That's where you're tuning in from right now. We have lots of content that we then, after the sessions conclude, put on demand. We also have some pre-recorded series on there as well. So definitely check out and scroll around, search through our channel for topics that interest you. And And then you can also find us on Twitter. Right now, our website is undergoing some updates, so it is presently offline, but it should be back up and running in the next month or so. And once that happens, we have a calendar featured there that you'll be able to sort directly for topics. I know on Meetup, we kind of put a little bit of everything on our calendars, and sometimes it can be hard to find the subjects that matter to you. So just know that when that website is back up and running, it will optimize that feature. So Louise, I'm bringing you back up onto the screen. We had a couple of questions come in while I was just running through that. So we have Sean asked again, another question. Can the training data have both categorical and numerical fields?
Yeah, that's also a good question. So currently for both training and the inference data, we only accepted the numerical data. So I think no other formats is supported right now.
Great. So we have a question from Christian. What is the minimum amount of information needed to detect anomalies?
I think what you mean is probably for both training and inference. So for training part, we don't have a really hard restrictions like how many data points and how many timestamps you have to input into the training model. So what we suggest based on our previous experience and experiments is that, for example, if you have around like 10,000 or like 15,000 of timestamps, that would be good for a starting point. So if you have less than that, like few thousands of the timestamp, that should also be good. But if you have just only like hundreds of the timestamps to train a model, that will probably not have a really good model performance, because sometimes just for like hundreds of timestamps, the model cannot learn a really pattern or a regular pattern or some rationale amount within this data. So that's for the training part. And for the variable thing, we support at most 300 of 300 of variables. So if your case have like 15 to 30, that is definitely okay. And if you have like hundreds of like 20, 100, that will also be fine. Yeah. And for the inference part, we don't have actually a hard restriction of that. We have a restriction on the inference based on the sliding window length. And the sliding window is actually maybe a new concept for you guys here, because today I didn't give some introduction to this sliding window. So the sliding window is actually what you will set for both training and inference precise. And this sliding window will help you to learn, or help the model to learn, like within the sliding window, what happened to the last data point within the sliding window. And the sliding window will continuously go by, just like the demo I showed you for the univariate part. And every time it goes, it will learn the sliding windows pattern, and it will detect the last data point. So for inference part, the hard restriction, if I have to say, is at least one sliding window length. And that's basically what you need for the inference part. And actually for the sliding window, you can set based on your data pattern. And the default number for our case, for our number, is 300. And if you have something really, if your data is really in a regular pattern, for example, like your data, like every month it have a pattern, a really similar pattern, you can just set 1 to 3 months, that is 1 to 3 cycle for the sliding windows for this setting. So basically that's the some restrictions and some regulations of the retraining and both the inference data input.
Awesome. Thank you. Do you have a couple more minutes for a couple more questions?
Perfect. Okay.
Okay, perfect. So Ishan has a follow-up. So they originally asked, can the training data have both categorical and numerical fields? So their follow-up question was, does that mean we can convert categorical data to numeric, and can that be used?
Yes, yes, definitely. If you have something category that you can transform to numerical, that's definitely acceptable. And that's really helping for the model to learn. For example, if your I can say a real case, if your equipment has some category field like whether this is on or this is off because the equipment will start and restart and stop, etc. So this category could be transformed into 0 and 1, and that's also really valuable thing for the model to learn because this will have some relationship with other sensors because one is 0 or to say one is off for the equipment, the variable might look really different with the other thing, with other conditions like the time is 1, right? So it's definitely great and it's really acceptable. Actually, it's recommended to convert your category which are related to other sensors to some numerical field.
Awesome. And they had a follow-up question to that question. They asked, is there a limit to the number of columns that can be the part of training data set?
Sorry, can you repeat?
Is there a limit to the number of columns that can be
Mhm.
used to be part of training the data set?
Okay, I think what you are asking is about the limitations of the variable number of training and inference, right? So if that's so, I think for training for an inference, as I just mentioned, at most 300 of variables, that will mean that except for the timestamp column, the last column should be at most 300. Yeah, I'm not sure whether you are clear about that.
Sorry, I was muted. Sorry.
Okay,
The
never
fun
mind.
times of live. So I think that was the end of our questions. We had some pretty good engagement in the chat, a good amount of people tuning in. So thank you all for being here and being a part of this session. Thank you, Louise, for taking the time. Louise is coming to us from around the world. For me, it's 1 o'clock. For you, Louise, I think it's 1 a.m., right? Or something like that. So
Yes,
I really appreciate you taking the time and coming on so that you could reach our audiences here on this side of the world. Really appreciate it. I think this was a fantastic session. Thank you so much for doing it. And again, to our audience, if you have more questions or questions that went unanswered, feel free to reach out to us on the Reactor meetup pages. We can always circle back and get those questions answered.
great.
Until the next one, thank you. Bye.
Thank you. Bye.